And by the way, I think I said this last time, on the test, I will give you the instructions for each one. I'm not going to make you memorize the constructions, yes? I make it a general rule to not make you memorize anything I don't have memorized myself. Also, it's not something you have to memorize. You just have to be able to follow the instructions, yes? So let's take a look at this new sheet here. Let's do this, just to get back in the swing of things. Can you guys, here, let's see. Oh, by the way, does anybody need a ruler or something? Anybody need a straight edge? Yes. And everybody's got a compass, is this true?
I need a compass.
Huh?
I need a compass.
You need a compass, okay. Don't we all? Let's see. I got one for me. Let's see if this one works. Did you just close the bag, Jeff? You did. I think this one works. Let's see. On the radio. On the radio. Yes. Okay, good. Straight edge. Got more over here. Somebody else need a straight edge? Yes? So everybody else got a straight edge and a compass, correct? Do you need some? You've got what now? Oh, you right on here? Go for it. Report back to be here at fireworks. Oh, compass, okay. That could be a more difficult thing. Let me see. On the radio. One of these is horrifically broken, and the other one is, oh, this one's fine. Okay, maybe? Yeah, no, he's not fine. Damn you. Okay, so, yes. Yeah, the lock is not cooperating. The lock is not locking. All right, poor little dude. I mean, I could. No, all right, just. I'll figure something out. Oh yeah, that's right. I got the Monster Man. That's one over there I could use. All right, let's see. Did I get that? Yes. Oh, so nothing's working. Neat. Let's see. Oh, something's working. Oh, there you go, Jeff. This was on. Okay. Let's see. I think it should start booting up. Hey, all right. Well, almost everybody's cooperating. Let me see what I can do here. Okay, you're all for decoration. I'm gonna let it sit there for a second. So what I want to do is I want to try to redo copy and angle. That's construction B. Just in case somebody wasn't here yesterday, also we're gonna have to do that again here in a little bit. So I just want to remember how that works. So if you've got your sheet from last time, it's construction B, copy an angle. So give yourself an angle, be nice to yourself, don't make it too big. Hey, all right. Now okay, I was gonna say that. So construction B. And as we did these yesterday, I tried to point out the theorems that we've talked about before that relate to what we're doing. So here, this is basically like side angle side kind of construction. So behind all of these constructions, it relies on congruent or similar triangle kind of ideas. What we're going to see today relies on some parallel line ideas. Let's all try to do copy an angle. I'll do this with you. So, get this badass out of his bag. Give yourself an angle. Make it relatively small, just because. There we go. Look at him. Aw. I'm going to call this angle A. That's crazy. So all I have to do, let's see, I'm going to catch up to you guys. So if you've got your little angle created, I'm going to put the point on A and open it enough so it's kind of like further down the line. If I make an arc, it'll go through both sides of the angle. So then I can call this B, I can call this C. Okay, so I don't know if you guys are ahead of me, keep going. If you're going with me, the next thing is get your compass open to AB, make sure it should have just been, but just double check. So I got radius AB now, for sure. So I put my compass at, where am I at? Oh, I gotta make my ray PQ, I forgot. So given an angle and given a ray, I'll put it down here, I think. So I think I told you guys on the actual test, I'll give you an angle and array, whatever it is that we need. If I want to make this array, it really should be like, yeah. Okay. So I'll give you the parts you need, and then you just have to build on top of them. Yes? Okay. So put your compass point at P, and then intersect PQ. You double check. Yeah. Intersect PQ. Wow. I'm going to call that little dude R. Now I want to change things up. Now I want my compass to be open to a radius of CB. So that is roughly, that is CB right there. Yeah, so I got it set at CB. And now I want to put the point at R and then make a arc here. Are you doing okay? Poor little guy. And I'm going to call that little dude, you're not going to believe this, I'm going to call this little dude S. And then I just draw through P and S. I went a little too far above. Darn it, I think my answer is going to be a little bigger than it should be. But if you took a protractor to those two, as long as you're within a couple degrees, you're fine. So if it's supposed to be like 31 degrees and you get 33, or you get 29, golden, yes. So what I'll most likely do on the test is I won't let you use a protractor. I'll give you an angle to copy. You copy it. You don't have a way to kind of check yourself, but that's the way a test normally goes. And then I'll just measure afterwards and see how close you got to the actual angle. You guys come with me? Okay. I am so aware of the mistakes we can make as humans. I know I made a mistake there. I know I did. Because my little line, see how it's above point S? So my angle's a little too big. You guys got it with me? Okay. How do you guys feel about that construction? Is that okay? So let's look at the new ones. Let's look at today's constructions. What have you done with the sheet, Jeff? There she is, okay. So today's construction, last two constructions, this is the last two new bits of information I'm going to give you, officially. Are constructing a perpendicular line through a given line, through a point not on the line, good Lord, and then the same thing but making a parallel line. So you're given a line, and you're given a point not on the line. So you're given this. And I want to construct a perpendicular to this line that goes through that point. Now, real quick, we already talked about how to construct a perpendicular to a given line, correct? But it didn't have to be through any specific point, so this is a little bit different from that. It's got some parts that should feel very familiar, but let's see. Can you guys, all right, I'm going to unleash you on this one. I'm going to shut the hell up. You guys try to follow the instructions, and then I'll come in and try to do it. Let me know if you need some help. Let me know if your compass is freaking out or something. They do that in various ways. Huh?
Freaking out.
Yes. Compasses, this is finding ways to freak out. By the way, Sierra, who's also teaching 125, she and I are talking to people if they knocked out that math 128. It's currently not planned to be offered. Neither Sierra or I have ever taught 128, and the people that have taught it in the past have retired. So that makes it really interesting. I think some of you guys might have already emailed our chairs about the fact that we're not offering 128. The more they hear that, the more there's going to be pressure on our dean to try to include it in our schedule. And then if we can include it in our schedule, then Sierra and I could work on actually putting it together for Grossmont. Yeah.
Are Cornhuskers are out for 128?
In the fall?
No, in spring. I'm
Spring.
thinking right now.
So our long-term goal is to kind of like work with Bianca and kind of like trade. One school does it in the spring, one school does it in the fall. Yeah. But at the moment, Grossmont doesn't have, it's not, 128 is not in our fall schedule, correct? No. Yeah. It would make a lot more sense if we could offset the offerings between the two. Anyway, just to let you know, things are being worked on as far as 128. Sorry. Slow, so we'll see what happens. So I'm supposed to place the point of the compass at point P. I got to open it enough so I know I'm going to actually intersect the line, but not too much. So if I intersect the line once, twice, 3 times, so that actually creates these 2 points, A and B. I like it. Now, real quick, can you guys look back at perpendicular bisector on the page, on the other sheet, the sheet from last time? The only difference between what we're doing right now and what this one says to do is that it gave us AB to start with, yes? What did we just do? We just found our own A and B. And then the process is actually the same after that, except the really nice thing is I've already got one side that has a point sitting there. So whereas this process required me to do arcs, intersecting arcs on both sides, I only have to do intersecting arcs on one side. Okay. So there's a connection between the two. Oh man. So now it says, with the same compass opening as in step 1, let me double check. Yeah, it's close enough, I think. Oh, Jeff, it doesn't have to be perfect. Okay, that's good. Place the point of the compass at A, and on the side of the line that is the opposite side from where P is, make a little arc. Yeah. And then from B, do the same thing. Woohoo! So now this pretty much looks like that. Is everybody okay out there? You guys all right? And now I just draw through. What did it say? Call that Q or something? Yeah, it wants me to call this Q. Why not? We'll call that Q. And then I construct line PQ. See if I can do it better this time. Jihad. And visually that looks pretty much like a 90-degree angle right there, yeah? So I feel pretty good if I'm on a test and my asshole teacher won't let me use a protractor. It looks pretty close if it's not perfect, yes? Can somebody tell me, could you make a 45-degree angle using what we just did? I mean, not the process, but the results. How would you make a 45-degree angle?
Because if that's 90 right there, I can just like cut it around.
Visually, or is there a process?
I feel like there's a process to it, but.
Probably. So look at the old sheet from last time. Like, now it's like, I can do that stuff. I can do it blind. You can feel the lead on the paper. So, yes.
Is bisect an angle?
Yeah! Sorry, I'll calm down. Yes. So if I give you, where'd it go? Bisect an angle. So if you construct a 90-degree angle, you can bisect it. Can somebody tell me how to make a 22.5 degree angle? Some of you guys are like, no, I cannot. And that is the answer to your question. Well, if I can take a 90-degree angle, cut it in half to make 45, I then have a 45-degree angle, correct? If I cut that in half, what do I get? 22.5 degrees. Yeah. Are you guys with me? So, in case some crazy math teacher gives you a test and it says, construct a 22.5 degree angle, what do you do first? Make a 90-degree angle. Second, cut that in half. Third, cut the half in half. Okay. Some of you guys are looking at me like, you wouldn't do that, would you? Okay. Now look at this next part. Why is this one a little deceptive? Why is that one deceptively short?
If you go back to
Yeah, step 3 says go copy an angle. So try this one also. Go ahead and try to follow these instructions. Step 3 could potentially be weird. But we'll see what you guys think. Try to follow the instructions for construction G. Construction instructions. Okay, start. So that's what you're given. Yeah. Think so? Maybe? We'll find out. Okay. I'll let you know. All right, let's see. I'm going to catch up to you a little bit here. Let's see. So I'm going to pick Q to be somewhere on line L. And then I'm going to make PQ. Oh, this poor little dude, he's kind of small. Let me, poor little guy. There. Okay. R is another point on L, so I might as well kind of put it relatively where the same place the instructions put it. And then I need to construct, oh, I shouldn't say construct PQR, I should say copy PQR, that's my fault. I want to construct, here, this is my fault. I want to construct, let me give a little point up here. Everybody add a point S there. We want to construct QPS. Jeff. Using the copy and angle construction process, copy PQR. Now real quick, you guys can see the image. PQR I've got, so I've already got PQR, I don't have to construct it. Come back to me, come back to me, there you go. I want to construct something here that's the same angle as this, yes? So I want to construct QPS so that that angle is the same. Are you guys with me? What is that related to? Why does this end up doing what it's supposed to? What's up with those? No. These angles. Yeah, if we copy that angle, it's going to be congruent. And what does that relate to in terms of parallel lines? Okay, PQ would be the transversal. What are those angles? There's something. Are they outside or inside?
Interior angles.
Interior, and they're also alternating, right? So they're alternate interior angles. Yes? I'll answer whatever you say. You don't necessarily have to remember the names of them, but you should see if line M and line L are parallel, then those two angles are the same. If those two angles are the same, then the lines are parallel. It works both ways. So we're using alternate interior angles backwards. Normally we're given parallel lines and we know the angles are the same. Here we're forcing the angles to be the same, so then the lines end up being parallel. I think it's kind of nifty, but I am also a very strange person, so. This might get a little freaky. If you go back to copy an angle, we're at sort of strange orientation. So I have this ray already, and I have this angle here. So this is angle, what we would, in the construction would be called angle A. Yes? And I want to end up copying it here. So let me see, what's a good way to help you guys keep this straight? We could, let me think. Yeah, we could kind of rename things right now. Do you guys, let me check in with you. Are you having trouble keeping things straight because the letters don't match up, things are a little bit off kilter? Anybody? Yes? Okay. So let's do this. Let's call this A instead of Q. So that's angle A now. Yes? That's the angle we're trying to copy. And if you go back to like, oh, where did I put it? And here is going to be, well, this is where things kind of suck. This is angle A, and this is the ray PQ here. So this is going to get a little bit interesting. So let's see if we can follow this. Okay, so it's going to be A and Q sort of. So I want to copy this angle A. Maybe I could do this. Let's do this. Let's keep this point Q, but we'll call this angle A. Okay, let's try that. So first thing, put the point of the compass at Q. Well, this is where things are going to get a little bit strange. So the point is Q. Open the compass a bit, construct an arc that intersects each side of the angle we're trying to copy. No worries. Oh, Jeff, keep the point there, dude. There you go, buddy. Okay. So this is the angle I'm trying to copy. So I want to have that go through both sides of the angle. Thankfully, these names aren't taken already, so I'm going to call them B and C. So now with the compass open to A and B, I put the point of my compass at P, which is right there. I could use that P right there. Construct an arc that intersects PQ. Let me see if this is where I want to do it. Let me think. Bup, bup, bup. Oh yeah, this will work. All right, so I've got my compass open to AB. And now I put my point on P and I intersect PQ. And that one we call, please give me an, yes, thank you. We call that one R, which is already taken, damn it. We'll call this one R2. Okay. Now, place the point of the compass at C and open it to a radius of CB. Let me stop for a minute. You guys kind of with me? This one's a little trippy because it's got a lot down there already. So CB. CB. Okay, now I'm open to CB. Put the point of the compass at R. For us, it's R2. And construct an arc of radius CB intersecting the first arc you drew. Oh, I didn't make this one big enough. Damn it. All right, let me go back. Sorry, I forgot all about that part. So I gotta go back. So this little dude right here, I didn't make him long enough. That was my fault. So I need to go back to radius AB. Okay. And then I go to P, and let me just extend this poor little guy a little bit. There we go. Okay. Okay. Now I can come back. Radius CB. CB. There I am. Put my points at R and then intersect what I just drew there. Okay. Woo! Call that point S. Sure, why not? Draw a straight line from P through S. And then these two should be parallel. So one little shaky step was I just didn't draw this arc long enough. Okay. I like the bemused looks of it. That construction is difficult because it's got an entire construction that has to happen in the middle of another construction. So in terms of the names you assign to points, if you're about to start another kind of process, you can rename things. They don't have to remain the same names they were, just so they kind of match up with the instructions you got for that process. Okay, that'll make that a little bit easier. I want to point out something on the practice test. I gave some different types of problems. I'm considering having one or two basic constructions, and then a problem like number 9 or number 10. Number 10 relatively should be not that. Well, let's see, I don't know. Number 10, I would ask you to make a 45-degree angle only using a compass and a straight edge. So we talked about that earlier, exactly how you would do that, right? Look at number 9 though. Number 9 is very different. So the idea is you would pick a vertex and you would draw a line to the opposite side, to the midpoint of that opposite side. So I would take like this and I would draw it to the midpoint. Do we have a way to find the midpoint of a given segment? Do we have a way to find the midpoint of a given segment? What would the midpoint do to a line? It would cut it in. To a line that could cut it in half. Do I have a way to bisect a segment? This guy actually does it here. It'll bisect the line segment. You guys with me? So if you do this, you happen to create a perpendicular, but where it meets, it cuts that line segment in half. So if you do that for each side, you'll find their midpoints. Right? One thing I was thinking about doing for that, well, I'm not going to do this, I don't think, but I was considering trying to go get like paint stirrers or something. You know, they're basically rulers that don't have any tick marks. So you truly just have a straight edge. But I'm not going to do that. You guys can have it. So you can check. If I ask you a problem like this, you can check to make sure you actually got the midpoint. Yes? Should be equal lengths on both sides. So number 9 is just sort of an example of using constructions to do another problem. So this problem requires you to do the same construction 3 times, and then you end up with something interesting in the end. Or, you know, what I hope is mildly interesting. So you guys can give number 9 a try at some point. What about, does this look familiar? This kind of situation? Well, I didn't tell you something about GH and EF, but what must be true about those in order for the triangles they create to be similar? What must be true about EF and GH? Must be parallel. I didn't indicate that they are, but how do you know they are? If they're parallel, then FI is a transversal. But just because FI intersects both of them doesn't make them.
Oh, they're 90 degree angles.
Okay, what about this? What kind of angles are those? Sure, but related to each other. So if this isn't transversal, and these two lines are parallel, those two angles are they kind of like in the same place in each situation? So there's a word that starts with the letter C. No. Or corresponding. They're corresponding. There's a correspondence between them in terms of where they are. Yes. Okay. Another way to say it is, this is a perpendicular perpendicular to this, and so is this. So therefore, these two must be parallel to each other. Yes. Oh, not to figure out that those are parallel.
I mean, just for the problem, like to get at the bottom two.
Oh, sure. I mean, so you could get like HI immediately, right? Beautiful. But then you have to use similarity rules to get the other ones. Yes? Okay, I like it. So real quick, can somebody write a similarity statement between two triangles in that figure? What two triangles are similar? What two triangles are similar in that figure? Well, somebody just tell me two triangles that are in there. EFI and GHI, right? And those two are similar. Can somebody tell me why they're similar?
They share two angles?
Yeah, so in that case, they must share three. So it's like, when we started with angle, 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 and then we cut it down to angle, angle. Because we got angle, angle, we got angle, angle, angle. Okay. Say that enough, you sound strange. But so I know that EFI. So if I needed to write a similarity statement for somebody, EFI would be similar to GHI. Just make sure that all the stuff that line up kind of go in the same spot. And then from this, you could set up the appropriate ratio. So like Leah said, Jeff, man, I could just get HI. This is a freaking right triangle, and an old Greek dude did stuff. I'm like, yes, totally. But if you want to get what like EG is, that's going to take a little bit of work, yeah. Okay. But I have no problem. Yeah, you can totally get HI from Pythagorean theorem. Kid gas. Can somebody tell me what the scale factor is between those two triangles?
2?
No. I see why you say that, but it's not an additive idea.
No, like times 2.
Oh, no. What side, I hear you over there. What side is congruent, is similar to EF? What side would be in a ratio with EF? GH. Do you see that? And I didn't multiply 3 to get 5. What did I multiply 3 by to get 5? 5/3. Right? So I can make that ratio, and so therefore the scale factor would be 1.6. You guys with me? 5/3, 1 2/3, 1.6. You guys, is that right? So what side is similar to GI? EI, I love it. Kick-ass. Sounds like we're about to break into song, but if I multiply 3 by 5/3 to get 5, what do I multiply 6 by to get EI? Same thing, 5/3. Multiply by 5/3, it's clean. And it's actually correct. 1.7 is not right because you approximate, yeah. 5/3 times 6 is easy because 3 goes into 6. Yes? Is that okay, you guys? Is that all right to get started on that problem? Okay. I can't remember, but I think I might have even pointed this out. This I just stole it from the book. By the way, I put this together this morning. I was like, oh crap.
my entire life here for the last couple days has been grading this one test because I never can. I like to give it back the next time I see them, which is bad for me, but that's just too bad. Yeah, okay, I like it. So I am so cool if we have an exceptionally early day today. I am beyond cool with that. But if anyone has any concerns or whatever, next Monday will be review day. I'll have the answer key for this. Yes. Next Monday, come ready with questions from homework. We could do some construction stuff together if you want to, or we just review all the similarity, congruence, rule stuff. Did anyone borrow something from you today? I think if you got a compass and you don't have a compass somewhere, you can keep it.